The sun's atmosphere should be getting colder. Instead, it becomes dramatically hotter. The bright surface we see burns at about 5,500 degrees Celsius. Floating above it is a faint halo where temperatures climb beyond 1 million degrees. Every instinct built from ordinary experience says this should be impossible. Step farther away from a fire and the heat fades. Yet around the sun, the opposite seems to happen. During a total solar eclipse, that strange halo briefly emerges from behind the hidden solar disk. It appears delicate and ghostly. Light stretches outward into darkness in thin, glowing strands. For generations, astronomers watched it appear and disappear in silence. The sight inspired wonder. The measurements it concealed did not. If those measurements were correct, then one of the most familiar objects in the sky refused to behave like any ordinary source of heat. The simplest explanation was that the observations themselves had to be wrong. That assumption felt reasonable. Scientific instruments improve. Early measurements are often corrected. Given enough time, the paradox would surely disappear. Instead, it became harder to dismiss. During the eclipse of 1869, astronomers aimed spectroscopes toward the glowing rim surrounding the hidden sun. The instrument separated the light into individual colors, revealing a brilliant green line that matched no known element on Earth. The result was so unexpected that researchers proposed an entirely new element. They named it coronium. For decades, that mysterious green signature remained trapped inside photographs of the solar corona. Eclipse after eclipse, the halo returned carrying exactly the same impossible fingerprint. The observations refused to change. Then atomic physics changed the question instead. Scientists eventually demonstrated that the green light was not coming from an unknown element at all. It came from ordinary iron, but iron stripped of 13 electrons. Creating that state requires temperatures exceeding 1 million degrees Celsius. The mystery had not disappeared. It had become undeniable. The strange halo surrounding the sun was not merely glowing. It contained atoms exposed to conditions hundreds of times hotter than the visible surface beneath them. Different observations reached the same conclusion. Better instruments had not rescued ordinary intuition, they had trapped it. The question changed. No longer, are the observations wrong? Now it became, where could that energy possibly come from? The visible surface no longer looked like the obvious source. Attention returned to the corona itself. Modern observatories captured the halo in wavelengths invisible to human eyes. False color images revealed structures hidden inside the plasma. Instead of drifting like smoke above a flame, the glowing gas formed immense arches stretching across space. Brilliant loops rose high above the surface before bending back toward it. Dark gaps opened between them. The entire atmosphere appeared woven into an organized framework. The pattern mattered. If heat alone were spreading outward, the atmosphere should have looked far smoother. Instead, these towering structures followed invisible paths with astonishing precision. The plasma was tracing something stronger than ordinary thermal flow. The sun was no longer behaving like a giant campfire. Its atmosphere was behaving like part of a vast magnetic engine. That realization replaced one mental picture with another. Energy did not have to travel upward only as ordinary heat. Invisible magnetic fields could store energy, reshape it, and release it into the surrounding plasma. The corona was not passively floating above the sun. It was responding to an unseen architecture. Yet even that new understanding left an uncomfortable gap. Recognizing that magnetic structures mattered was not the same as seeing the process itself. To understand what was really happening, distant observations were no longer enough. Humanity would have to enter the atmosphere itself. That sounded impossible for an entirely different reason. How could any spacecraft survive inside a region measured at more than 1 million degrees? The answer depended on another unexpected distinction. Temperature describes how fast individual particles move. Heat depends on how many particles are available to transfer that energy. The corona contains extraordinarily fast particles, but it is also extraordinarily thin. Compared with the dense layers below, there are remarkably few particles available to transfer their energy. That difference changed what was possible. Engineers built a spacecraft capable of approaching the Sun more closely than anything before it. Behind a thick carbon shield, delicate instruments remained near room temperature, while the shield faced an environment that seemed unimaginably hostile. The mission was never expected to deliver one simple answer. It was built to witness reality directly. As the spacecraft crossed into the Sun's outer atmosphere, it encountered sudden reversals in the magnetic field. Invisible structures twisted and folded back on themselves. Researchers called these features switchbacks. They revealed a magnetic environment far more dynamic than distant images alone had suggested. Direct exploration had succeeded. But the mystery did not become simpler. Instead of uncovering one hidden heater, the spacecraft entered a restless system where magnetic structures shifted constantly and energy moved through processes that are still being untangled. Competing explanations remained. Magnetic reconnection likely plays a role. Powerful plasma waves almost certainly contribute as well. The exact balance between those mechanisms remains an active area of investigation. The closer humanity moved to the Sun, the more complex its atmosphere became. The contradiction that began with a faint halo during an eclipse had grown into something far larger than a measurement problem. It had forced an entirely new way of seeing the nearest star. The glowing corona returned one final time. At first, it seemed little more than a beautiful ring revealed during rare eclipses. Then it became evidence of an impossible temperature. Later, it exposed the hidden framework of magnetic structures surrounding the Sun. Now it stands as the visible edge of a system that continues to challenge even the most advanced spacecraft ever built. Nothing about the Sun itself had changed. The photosphere remained near 5,500 degrees. The corona remained millions of degrees hotter. Magnetic fields continued shaping the plasma high above the visible surface. What changed was the picture inside our minds. The familiar image of a simple burning sphere could no longer survive. In its place stands a star governed by invisible magnetic forces, where careful observation overturned expectations built from everyday experience, and where one of astronomy's oldest paradoxes remains not a failure of science, but a reminder that reality often becomes stranger as the evidence grows stronger.